The power formula is P equals E times I, where P is the power with the unit of watts, is the energy using a unit of volts, and I is the current, which has a unit of amps. So let's say, for example, we want to find the power, find P, if E is 50 kilovolts and I is 25 amps. So P equals E times I. Now E, instead of 50, I'm going to change this to 50,000 volts, since kilo is 1,000. So 50 times 1,000 would be 50,000 volts. So 50,000 times 25 amps. So in this case, I'm just multiplying those two numbers together, the E and the I. 50,000 times 25 is 125 and then 4 zeros. So 1,250,000 watts. Now to change this to proper engineering notation, let's go 1, 2, 3, 4, 5, 6 to get my value right here to be between 1 and 99. So this would be 1.25 times 10 to the 6th watts. So 1.25 megawatts. Okay, now, one disclaimer, this might not be realistic numbers that I'm using these examples, but more about using the formula and calculating and getting to proper engineering notation. Practice with that. Let's do one more. Let's say, for example, we want to find P, the voltage, if P, the power, is 10 watts and the current I is 800 amps. So we're plugging again into the formula, P equals E times I. Maybe this time I'm going to write it down. P equals E times I. So P is 10 watts equals, I don't know what E is, times I is 800 amps. So in this case, we have to solve for E. We have to do a solving equation step here. To get E alone, divide both sides by 800. So on the right side, the 800 cancels. I'm just left with E. 10 divided by 800 is 0.0125. And this is not in proper engineering notation, so I'm going to move 3. And now 12.5. This is a number between 1 and 999. It's small, so this is 10 to the negative third. And I'm going to add my unit of volts now for E. 10 to the negative third is millivolts, so 12.5 millivolts. And I just realized I have the same numbers, 1, 2, 5, in both examples. That's coincidence. Just coincidence there.